Formative tomorrow. Quiz on Thursday. Formative next week, Tuesday. Test next week, Thursday. Side note, you will probably need a calculator for figuring stuff out today. I mean, you don't, but it's probably going to be faster for you. So, totally up to you. Agree.
Yes.
Green agree.
Yes.
Agree with solving the blue equation for G sub 1 and getting negative 3 divided by R. Plugging that in for G sub 1 in the green equation and getting negative 243 equals negative 3R to the 4th power.
How did you do that?
Substitution.
Yeah, I got negative 3 over R times R to the 5th. And then I know to the 4th.
Simplify your powers.
So you just cross the bottom out.
Well, what's R to the 5th divided by R?
R to the 4th.
Mm-hmm. Now what? Divided by negative 3. Now what? Fourth root. Gets me what? Nope. Plus or minus 3. Even root. Got to add the plus or minus. So that gets me 2 rules. G sub n is equal to negative 1 times the quantity 3 to the n minus 1 power. Or G sub n is equal to positive 1 times negative 3 to the n minus 1 power. And again, if you put that positive 1 there, that's fine. That one's doesn't have to be there because we're just multiplying by 1. the -1 from the first rule, right there, that has to be there because that is a value that we need. Okay? Did that answer your question? All right. Not going to lie to you. A lot of math going on today. Okay? It's not hard math. Okay? But there's a lot of calculation math going on today. Okay? Just so you know. So get yourself ready for it. Okay? The sum of a finite geometric series. Okay? So we're going to find the sums of geometric series today. Sometimes it's nice because you have whole number R values. Sometimes it's not nice because you have fractional R values. Just the way we have. Sometimes things are all unicorns and rainbows, and sometimes it's a hurricane outside. Okay, so let's do it. Okay. There are two geometric sum formulas. Both of them will get you to the exact same destination. It basically ends up being a personal preference as to which one you want to go with. Okay? I would stick, if it were me, I would stick to this side, or the left side one. I would stick to that one if R is an integer. Would be my personal preference. Okay? Because if you look at the formula, you're taking R to a power. Okay? So if R is an integer, like 2, well, I can take 2 to any power and I can figure out what that is. Okay, that's going to be nice. But if I'm taking a fraction to a power, that's not so nice. Okay? Okay? So I would stick to the left one if R is an integer, and I would stick to the right one if R is a fraction. Okay? But again, that is just of my own personal preference for that. Both will end up getting you to the exact same spot, to the exact same answer. Okay? So, we've defined all of those terms before. S sub n is the sum of the first n terms of a series. N is the number of terms. G sub 1 is the first term. R is the common ratio. G sub n is the last term. I think that's all the terms that we have to define. Okay? So, the more important question is, where will we find all of that stuff? Okay? So where am I going to find n, for instance? Okay? Well, n comes right there when I'm just given the rule, or it's in the directions. Find the first, or the sum of the first 8 terms, etc. Something like that. Okay, and then n would be 8. On this side, remember n is my end or my top term, minus my start, or my bottom term, plus 1. When I'm just given the rule, that's G sub 1. When I'm given sigma notation, remember I have to plug the start value into my rule. Over here, I'm going to plug n into my rule to find my G sub nth term. In sigma notation, I plug my end into the rule. Over here, R is given to me. In sigma notation, R is the term, or the number I should say, with an exponent. In the rule. In the last class I said R has the power. Okay? Because R is the only term that has an exponent on it. In either case. In either when I'm giving you the rule or when I'm giving you summation notation. R is the only term that has an exponent. Okay? So in this particular one, it's the something. Okay? All right, let's do this. Okay? Quick once over of this problem. Okay? What is my R value? It's 1/2, because it's the term that has the exponent. Okay? So my R is 1/2. Now, I could use this top rule, but I would have to take 1/2 to a power, which is just going to make an even uglier fraction because the numbers are going to be bigger. Okay? So I might not want to use this one. Down here, I don't have to take R to a power. So maybe that's the one that we use. Okay? The downfall with the bottom one is I need to find G sub n. Well, before I find G sub n, I should probably figure out what n is. Okay? What's n in this problem? Well, yes, 6. 6 minus 1 plus 1 is 6. Yep. So now I can find G sub 6, which is my last term. So I'm going to plug that into my function. Six minus 1 is 5. One half to the 5th power is 1/32. So my last term ends up being 1/8. Still need my first term. One minus 1. 1/2 to the 0 power times 4. 4. So my first term is 4. Okay. So if I'm utilizing that formula, this would be the sum of the first 6 terms is equal to my last term times my R minus my first term all over 1/2 minus 1. One-eighth times 1/2. Say it louder. 1/16. Instead of writing 4, I'm going to write 64 over 16. Why did I choose it to write it that way? Why? But why did I choose 64 over 16 and not 16 over 4? Common denominators, yep, because we had common denominators in that case. Yep, okay. And then 1/2 minus 1 is negative 1/2. 1/16 minus 64/16. No. That'd be 64/16 minus 1/16. Negative 63/16. Big difference. When I'm dividing by a fraction, what do I do? Multiply by the reciprocal. So the reciprocal here would be negative 2 over 1. Negatives cancel out. 2 goes into 16 8 times. So the sum of my 6 terms is 63 over 8. I told you, but it's not hard work though. You know what I mean? There's just a lot of it. It's a lot of computational math today. And unfortunately, there's no way around it. because geometric terms aren't nice and neat where they're always the same gap between the terms. Okay? You find me, now, the sum of the first 10 terms of that geometric series. R value. Fractional R value tells me I probably want to stick with that one then, right? The bottom one. Okay? So I need G sub n. Well, G sub n in this case is G sub 10. Because I need to find the sum of the first 10 terms. 4 times 1/2 to the 10 minus 1 power. 10 minus 1 is 9. So this is 4 times 1/2 to the 9th power. 1/2 to the 9th power is 1/28. I think. 5 gets me 32, 6 is 64, 7 is, nope, 7 is 128. 256 is 8. 512? Oops, that times 512. So then that knocks it down to 1 over 128. Okay. Got my last term, got my R, need my first term. We said my first term was 4 because it's in the problem. Got everything else. All right, so the sum of the first 10 terms is G sub n is 1 over 128 times R, which is 1/2 minus 4 all over 1/2 minus 1. So that's 1 over 256 minus 4. Now I want 4 in a denominator of 256, so that's going to be 1024. Okay. So this becomes then, oops, went too far, negative 1023 over 256 times the reciprocal of the denominator. Negatives cancel out. 2 goes into 256. 128 times?
Yeah.
So I get the sum of the first 10 terms is 1023 over 128. Fractions are your friends. They will make it so much easier. As opposed to 7.99219. Okay? Plus they're exact. Good? Questions on it? Try that one. Since I have an R value that is an integer, we can use that top one. So then I need to find g sub 1. I find my first term by plugging 1 into my rule. Negative 2 to the first power is negative 2 times 10 is negative 20. N is going to be the top, or the end, minus the start, plus 1. So that gets me 15 there. So the sum of my first 15 terms is going to be my first term, negative 20, times negative 2 raised to the 15th power minus 1 all over negative 2 minus 1. Negative 2 there we go, raised to the 15th power is negative 32,768. Negative 32,768. Then I still have to subtract 1 from that, but then that's all over negative 3. Negative signs, those two cancel out. 3 goes into 32,769. 10923. If I divide by 3. So I get this, oops, then I got to multiply by 20. Negative 3 goes into that one. Oops. Forgot to subtract 1 first. Negative 218,460. If you're careful on how you punch it into the calculator, actually here I'll do it without, you can go negative 20 times negative 2 raised to the 15th power minus 1 divided by negative 2 minus 1. If you're careful how you type it in, you can type it right in and it'll do it for you. Okay? But there's many spots that you could make a mistake there. So if you do stuff individually, that's why I said it's a lot of calculations, a lot of computational math going on today. Not a lot of hard math, a lot of computational math. Okay? Find me the sum. First term is 18. R is 3. N is 5. $2,170. Yes, sir? Okay. That one is small enough too because there's only 5 terms where we could find, if you had to, if you forgot the formulas or if you didn't know how to do it, you could find the 5 terms and then just add them up too. Homework for this evening. Don't forget that tomorrow there is a formative. There's a formative in the Resource Center for you tomorrow. Thursday we will be having, or you will be having, a quiz on section 2.3. I might sprinkle in a couple of 12.1, 12.2 questions in there. You never know. Okay. All gearing towards next week, Thursday, then, of taking our test. If you haven't checked in a while, make sure you check your portal. If you're missing something, anything like that, if you're missing a quiz or a test from this unit or a previous unit or something like that, next week, Tuesday, is the deadline to have those done in order for them to be on the quarter grade. Okay? So you got until next week, Tuesday, to make up anything. Okay?
Are they all in the MRC?
Quizzes are, yes, formatives are not, but summatives are.